Dear students, Assalamu alaikum. Today I shall discuss another name reaction, that is Grignard reaction. Like other name reaction, here I shall discuss about the theory, reaction mechanism, application and limitations of Grignard reaction. Grignard reaction named after a French chemist Victor Grignard, who discovered Grignard reagent and developed their use as synthetic reagents. He was awarded Nobel Prize in 1912 for chemistry. The addition of Grignard reagent to aldehyde and ketone is known as the Grignard reaction. For Grignard reaction, we have to use Grignard reagent, which has the general formula RMgX and the general name alkyl magnesium halide. Typical Grignard reaction is shown here when aldehyde or ketone reacts with Grignard reagent. In that case, an intermediate compound will be formed which on hydrolysis yield alcohol. This is the typical Grignard reaction. For Grignard reaction, we have to use Grignard reagents. Grignard reagents were prepared by refluxing alkyl halide with magnesium in dry ether. During reflux, magnesium diffused between carbon and halogen of alkyl halide and formed alkyl magnesium halide. In alkyl halide, the carbon has partially positive charge and the halogen has partially negative charge. But in Grignard reagent, the bond between magnesium and halogen is ionic and the bond between carbon and magnesium is covalent but highly polar. Here carbon has partial negative charge, but in alkyl halide the charge of carbon was partially positive charge because magnesium is an electropositive metal than carbon. Now about the mechanism of this reaction. Mechanism of the reaction of alcohol synthesis from aldehyde and ketone with Grignard reagent is also known as the mechanism of Grignard reaction. This is a nucleophilic addition reaction. In step 1, the bond between carbon and magnesium dissociates as this bond is highly polar in nature, which I mentioned earlier. Then the negative ion of Grignard reagent will attack the positive carbon of the carbonyl group of aldehyde or ketone. After that, the pi electrons will move towards oxygen and this compound will be formed. In step 3, positive portion of the Grignard reagent will share the excess electron on oxygen, which was produced after step 2. After that, this compound will be formed, which on hydrolysis will produce an alcohol and magnesium hydroxy halide. This is the overall mechanism of Grignard reaction. Now about the application of Grignard reaction. We can use Grignard reaction for the synthesis of different types of alcohol. When we use formaldehyde, in that case primary alcohol will be produced after Grignard reaction. If we use other aldehyde, in that case secondary alcohol will be produced. But if we use ketone, in that case tertiary alcohol will be produced. We can also synthesize primary alcohol with 2 more carbon than the Grignard reagent. If we use ethylene oxide for Grignard reaction, we can see the reaction here. Similarly, we can also get tertiary alcohol if we do Grignard reaction using carboxylic acid esters. we can see the reaction here. We can get carboxylic acid if we do Grignard reaction using carbon dioxide. Reaction mechanism is same as the typical Grignard reaction. If we react Grignard reagent with water, in that case we will get alkene. We can get ether if we react Grignard reagent with halogenated ether. It is possible to get ester when we do Grignard reaction using Grignard reagent with alkyl chloroformate. The reaction mechanism is same as the Grignard reaction. We can also get primary amine when Grignard reagent will react with chloroamine. It is possible to get alkyl cyanide if we react Grignard reagent with cyanide. When Grignard reagent reacts with sulfur, in that case it is possible to get thioalcohol. We can prepare a lot of compounds using the reaction mechanism of Grignard reaction. Now about the limitations of Grignard reaction and reagents. Preparation and reaction of Grignard reagent should be done under moisture-free condition. All the apparatus must be completely dry, and the reaction system must be protected from water vapor, oxygen and carbon dioxide of the air, because in the presence of water, Grignard reagent will be converted to alkane, which I mentioned earlier. Grignard reagent cannot be prepared from a compound that contains, in addition to halogen, some groups like hydroxyl group, because as fast as a molecule of Grignard reagent is formed, it will react with the hydroxyl group in another molecule to yield an undesired product. In the last step of Grignard reaction, water hydrolysis of the addition product gives rise to a gelatinous mass of magnesium hydroxyhalide, which is difficult to separate from the desired product, that is from the alcohol. So to overcome such a difficulty, mineral acids such as hydrochloric acid, sulfuric acid can be used instead of water for hydrolysis purpose, as water soluble magnesium salts are formed. The reaction is stereospecific. If the carbonyl compounds contain a branched carbon chain, then the reaction will be slow due to steric hindrance. This is also a limitation. The Grignard reagent, particularly when aryl, should not contain any substituent in which hydrogen is directly attached to highly electronegative oxygen and nitrogen, like carboxylic group, hydroxyl group, amino group and sulfonyl group, because they are so acidic that they will decompose a Grignard reagent. The carbonyl compounds with which a Grignard reagent is to react may not contain other groups that are reactive to Grignard reagent. For example, nitro group, amino group, carboxylic group, because side reactions may occur. When a beta hydrogen is present in the carbonyl compound, enol may be formed. This enol exhibits an equilibrium with its isomer. Oxygen of the carbonyl group of the carbonyl compound will withdraw the pi electrons toward it. So the oxygen will become negative and the alpha carbon will become positive. This positive carbon will try to withdraw electron from the beta carbon, and due to this influence, hydrogen on beta carbon will be released as proton, and a new bond will be formed between the alpha and beta carbon. Hydrogen ion, that is proton, will form alkane with the negative part of the Grignard reagent after its dissociation, and the positive magnesium halide ion will form bond with the negative oxygen after sharing its excess electron, and a compound like this will be produced, which on acidic hydrolysis will be converted to an enol. And this is not our target product according to Grignard reaction. So we have to use such a carbonyl compound which doesn't contain any beta hydrogen. Formaldehyde is the only carbonyl compound for the preparation of primary alcohol using Grignard reaction mechanism. This is also a limitation. When a beta hydrogen is present in the Grignard reagent, reduction of the carbonyl group occurs. This is called redox reaction. This occurs due to hydride transfer reaction. Desired product cannot be obtained by this reaction according to Grignard reaction. This is also a limitation of this reaction. So these are the limitations of Grignard reaction and reagent. That's all about Grignard reaction. If you like my lecture video, then don't forget to click the like button. You can also share this video to your friends and can also put your comments. Lastly, don't forget to subscribe my channel. Your subscription will encourage me to make more lecture videos for you all. Thank you.